Okay, grade 11 pre-cal, lesson 52, linear inequalities in two variables. Now, this is an interesting thing. We're going beyond equal signs. We're going to less than or equal to, greater than or equal to, or just less than or greater than. Now, if you remember in grade 9 when we did this on a number line, we used open circles and closed circles to represent points. Well, if you look at this one, less than or equal to is going to be a solid line, and if it was just less than, it would be a dotted line. Let's start with that. Secondly, because we have inequalities, there's more than one solution. So you have to go through and you actually have to shade. Now, if you use a program like Desmos, or if you use a program like the TI-83, it'll shade this also for you. But let's go through this manually. So we got 2x plus 3y less than or equal to 6. For us to be able to graph this, let's turn it into a linear. Well, it is linear. Sorry, let's turn it into y equals. So we want it like slope-intercept form. So we move everything around. We end up with y less than or equal to negative 2/3 x, negative 2/3 x plus 2. Okay, so let's graph this. So positive 2, right? That's our y-intercept. Negative 2 over 3. And just go down 2 over 3, down 2 over 3, down 2 over 3. Then it's a solid line because it's less than or equal to. Pick a test point. So this is the easiest way to figure out shading-wise. And obviously, is if it's not going through the origin, pick the origin as your test point. Pick a simple point. So pick 0, 0. So what we're going to do is we're going to take 0, 0, and we're going to plug it into the equation. So we plug it in. So 2x plus 3y less than or equal to 6. So we plug in 0. We end up with 0 less than or equal to 6. Is that true? Well, of course it is. 0 is less than or equal to negative 6. So the test point is the solution. So that what we do is we shade on this side because that test point is part of the solution. Now, if it was false, where do you think we would shade? Well, of course, on the other side, right? And you can test that again. Pick a test point over here. Pick like 3, 3 if you want. And then you would find out that's the point you pick. So pick a test point. If it's true, shade on that side. If it's false, shade on the other side. Okay, second page. Let's go to another example here. So 10x minus 5y greater than 0. Again, rearrange this so it's in slope-intercept form. So we rearrange it. Now, you gotta remember some things from grade 9. Look here. Y is less than, greater than negative 10x. Divide both sides by negative 5. What do you do in an inequality when you divide or multiply by a negative? You got to remember the symbol is reversed. Now, don't forget that. That's a basic grade 9 thing that you got to remember. So we have y is less than 2x. How do we graph that? Right? The intercept is 0. The 2 means we go up 2 over 1, up 2 over 1, up 2 over 1. Hey, why did we put a dotted line here instead of a solid line? Because it's greater than. Right? If it was greater than or less than, it's a dotted line. Okay, let's pick a test point. Now, obviously, we can't pick 0, 0 as the test point because it goes through the origin. So let's say right here, pick a test point. 0, 0 won't work because the line goes through. So try negative 2, 3. Negative 2, 3. So up here in quadrant 2. So we plug it in. We plug it in and we find out we do all the work. Negative 35 is greater than 0. I'm no math teacher, but I don't think that's correct. So it's false, right? So since the test point is false, it is not part of the solution. So we shade on the other side of the graph, right? So because this point up here it was false, wasn't part of the solution, we shade on the other side of the graph. And if you're unsure about that, pick another test point. Pick one over here, like pick 3, 0. But if you plug that in, it's going to be positive. It's going to be true. It'll work. Okay. So again, rearrange your equation, graph the line, solid or dotted, pick a test point. Okay, now let's look at this last example. This is kind of neat. This one's kind of going backwards. So what we have here is we actually have a graph, and you have to figure out the equation that goes with it. Oh, okay, well, it's not that tough. First off, dotted line, so it's either greater than or less than. Nice. It's linear, so we don't have to, we can figure out, do we have a y-intercept? Yes, we do. The y-intercept is 0, 1. The slope, up 2 over 1, up 2 over 1, so the slope is 2. Oh, so there's the basic equation. Y equals 2x plus 1. But we know right away that equals sign. It's just a placeholder for now, right? It's either going to be greater than or less than. Okay, so since the line is dotted, we know it's either greater than or less than. So we can try a point. So what point do we try? Negative 2, 4. Is that part of the solution? Negative 2, let's check. Negative 2, 4. Yeah, it's part of the solution. So what we do is we plug in our values. So y is 4, x is negative 2. So we plug it in, we do all the math, So we end up with y equals negative 3. Now, to make this true, what's the inequality? Is 4 less than negative 3 or greater than negative 3? Well, it's 4 is greater than negative 3. So that has to be our symbol, right? We just picked our test point and we just worked backwards. Therefore, right, the 3 dots mean therefore, y is greater than 2x plus 1. So it's not that bad, right? You can figure out based on the y-intercept and the slope and the dotted line and then a test point. You can work your way backwards to figure out what the equation actually is in this case. All right?